Making a good diagram down on this question, and then sketch my triangle. Okay, it doesn't have to be really accurate. Just try and make it so it doesn't look like an equilateral triangle, I'd say, and try not to make it look like an isosceles triangle. But it's not going to matter too much. It's just to give us an idea of what's going on. So this one looks like it's the largest angle. We're going to call that 75. This one can be 45, and this one can be 60. Now somehow we've got to use the radius. So if I put the center in, I'm going to connect it up to the corners. These lengths are going to be 2. Okay, now at the moment, how those angles are not particularly useful. I've got two sides of a triangle. So if I could work out this angle here, I could use the formula half AB sine C, or in this case, a half times 2 squared times sine C. But actually, we're not far away because there is a circle theorem that says the angle at the center is twice that at the circumference. And that is happening here. Here to here, for example, which means that this angle here is 90. And then along similar lines, we've got this and this, which means this angle is 150. And the other one must be 120, either angles around a point or this same circle theorem. Okay, that is brilliant. You can alternatively do this question by calling this angle here S and T and creating simultaneous equations, but it's much better, much quicker to use this circle theorem. So I'm not going to go into any more detail on that, but you might want to try that one out. So I've got 3 triangles now, and I just need to find the area of each one, add them up. That'll give me the area of the triangle. So triangle number 1, let's go with this one in blue. Actually, it's going to be the simplest one. I've got a 90-degree angle. I've got 2 and 2. I don't need to use half AB sine C. It's just going to be a half 2 squared. It's going to be 2. Okay, second one. This one here in red. 2, 120. It's going to be a half 2 squared times sine 120. Now this might be the trickiest bit whether you have to know your value for sine 120. So let me talk a bit about it. Okay, the sine graph looks like this. This is 180. This here is 90. Now there is symmetry for the sine graph, which means that sine 120 is actually, because it's 120 30 away from 90 and there's a line of symmetry here, then it's actually going to be the same as sine 60. So it's going to be 2 sine 60. And sine 60 is root 3 over 2. Sine 30 is a half. Sine 60 is root 3 over 2. Remember that sine 30 is definitely smaller. Like that's what I always do. I sometimes get them mixed up. I remember sine 30 is smaller than sine 60, so it's got to be less. It's a half, and that one's root 3 over 2. There are other ways of memorizing these values, which I'm not going to talk about here. But that's going to give me 2 times root 3 over 2. It's going to give me root 3. So I've got root 3 plus 2. I've just got one more triangle. And that's this one here with an angle 150. Half 2 squared times sine 150. And for similar reasons, we can say, right, sine 150 is actually the same as sine 30. So it's 2 sine 30, which is 2 times a half, which is 1. And therefore, final answer, 2 plus 1 plus root 3, 3 plus root 3. Nice question.